Okay, guys, day 4. We're going to try to put all this together now. You'll remember on day 2, we talked about a central angle and the measure of an arc versus the length of an arc. Remember, measure of an arc is expressed in degrees. At a 360, how many degrees is in an arc? And we can also take the arc out, stretch it out, measure it with a ruler, which would be the arc length. And I just want to remind everybody what the formula was for arc length. All right, that was the measure of the arc over 360 times its circumference, pi d. Okay, now again, this was in degrees, remember. Okay, we always put the degrees there. That was in degrees. Okay, now we learned yesterday, day 3, that there's another way to express an angle, and that's in radians. So what I want to focus on today is, how do I find an arc length, but now instead of the angle being in degrees, it's in radians. Okay, so this is a new formula. So again, hopefully we're keeping track of our formulas, because right now you got circumference, you have the arc length when the angle's in degrees, and now I'm going to show you a third formula, which is how to find arc length when the angle is in radians. All right, and that is the following. Here's our symbol theta, which I'll talk about in a second. That's always means an angle measure. All right, theta is equal to S over R. All right, now let me go through each piece right now. All right, theta, that's your central angle. But again, it's in radians now. Not degrees anymore, it's in radians. Okay, we have S, that's our arc length. And then we have R. Some of you can probably guess what the R is going to stand for. That's radius length. Okay, again, this formula I can use to find the length of an arc, if the angle is in radians and not degrees. Okay, if it's in degrees, I have another formula right up here I could use. Okay, so here we go. So you take a look at number 1, find the length of arc S. Now, all right, it's arc length. I have 2 formulas to find arc length. So what I want to do is look at the degree, look at the measure of the central angle right here, and ask myself the following question: what type of units is that in? Is that degrees or is that radians? Well, this is pi over 3, so that must mean it's in radians. All right. So if it's in radians, I want to use the formula I just gave you guys, which is theta equals S over R. Okay, theta, actually, you know what? I'm going to do it off to the side here. Theta equals S over R. Okay, here we go. Theta is the central angle in radians, which is pi over 3, equal to S arc length, that's what I'm trying to find, over R radius length, 5. Now, how do I solve for S? I can cross multiply. I can multiply both sides by 5. All right, so go ahead and do that right now. You can do 3S equals 5 pi, divide both sides by 3, or you can multiply both sides by 5. Either way, you're going to have to go to your calculator right now because it's asking for nearest hundredth. Okay, so when you do that, the arc length should come out to be 5.24 centimeters. Okay. All right, let's go on to number 2. Find arc length S. All right, again, look at the central angle. 10 pi over 9. Is that radians or is that degrees? Is that radians or is that degrees? That's radians. So I can use theta equals S over R. What's my central angle? That's 10 pi over 9 equal to S, the arc I'm trying to find, over R, which looks like to be 27, the radius length. Same thing, cross multiply or multiply both sides by 27. and round to the nearest hundredth. So S equals, I'm getting 94.25 meters. Make sure we label our units if I'm given units. Okay? All right, now I know you guys are in honors, so maybe some of you guys are thinking, well, is it okay if I take my radian measures? So go back to problem number 1. Is it all right if I take pi over 3, which is in radians, convert it into degrees, which we showed on day 3 how to convert it back to degrees, convert pi over 3 into degrees, then use this formula up above? Sure, that's fine. Yep. You can always convert back into degrees. If you want to keep using that formula, you can. That's fine. All right. Just make sure you know what type of units your angle's in, because that'll dictate which formula you use. Okay. All right. Let's keep grinding. Let's go to 3. All right. Now we're going to actually find the angle. And it says in the directions, hey, now I need your answer in both radians and degrees. Okay, so we're going to have to find in number 3, what's my central angle here? Okay, I particularly like to start by finding it in radians because the formula is a little bit easier to use. Theta equals S over R. Okay, I am solving for theta now. When I know S, which is the arc length, is 8 pi over the radius, which is 16. Okay, so in radians, because this is the formula I would use if the angle's in radians, reduce 8 over 16, just like we did yesterday. And pi over 2. So that's the angle in radians. Now to find it in degrees, we just convert like we showed yesterday. All right, so let's go back. So in degrees now, anybody remember from yesterday, and it's okay if you look back, what do you have to multiply the radians by to turn it into degrees? What should you multiply radians by to convert it back into degrees? 180 over pi. Okay, 180 over pi. As you remember, the pi's will cancel each other out. And 180 divided by 2 in degrees, that is a 90-degree angle. Okay? All right. Again, could you have started with this formula on top and solved for the measure of the arc? You could have. That would have gave you your answer in degrees. Then you could convert in the radians. I just think this formula here, theta equals S over R, is a little bit shorter, a little easier to work with. So that's why I solved for radians first. All right, let's go to 4. All right, so we're going to solve. I'm going to start with theta equals S over R. So we're going to find the angle in radians. So theta equals 15 pi over 7 divided by radius length is 5. Okay, it's a little crazy to look at. You got a fraction divided by a fraction. You always want to remember, since we're going to find the answer in radians, you want to keep pi in your answer. So what I'm going to do here is I'm going to go to my calculator. And I'm going to get a fraction template. And in the top, I'm going to put another fraction template. I'm going to put 15 over 7 in the numerator. Denominator, I'm going to put 5. Whoops. Denominator, I'm going to put 5. And that ends up being 3/7. So going back, it's going to be 3 pi over 7. And now I got to turn it back into degrees now. And to do that, I'm going to multiply it by 180 over pi. Okay. So get rid of that, get rid of that. And we end up with, it's going to be a little bit of a decimal here. I'm just going to round to the nearest tenth and say 77.1 degrees. Okay. So hopefully we're starting to pick up here. There's two formulas for arc length. One is if the central angle is in radians. One is if the central angle is in degrees. Do you have to remember both? Sure, you can. All right, that's fine. But if you want to convert and only remember just one of them, like say you just want to remember theta equals S over R, fine. But if it's in degrees, the central angle's in degrees, you're going to have to convert and know how to convert it to radians so you can use theta equals S over R. All right, so hopefully you guys are just picking up on that as we finish up these notes here. All right, next up, little word problem. Pendulum of a clock. Ooh, stop it right there. Do we know what a pendulum of a clock looks like? I got you guys covered. That's what we're looking for right here. All right, the pendulum of a clock swinging back and forth here. All right, that's what a pendulum of a clock looks like. Just a little FYI for you. All right, swings through an angle of 2.5 radians. It travels through an arc of 50 centimeters. Find the length of the pendulum. All right, so if I take this to a circle, okay, here's my pendulum here. Okay, there's the pendulum of my clock. It swings through an arc or an angle of 2.5 radians. So that's telling me my central angle is 2.5. It's in radians. And it travels through an arc. So the arc length is 50 centimeters. Find the length of the pendulum. So what am I really looking for here? The length of the pendulum is the same thing as saying, hey, let's find the radius length. All right. Okay. So I'm given arc length here. I'm given arc length. So I have two formulas for that. So now I check the central angle. What's the central angle in? That's in radians. So I can use theta equals S over R. Again, you don't want to use this. You rather use the other formula from day 2. You're going to have to take 2.5 radians and convert it into degrees. It's your call, guys. Your call. All right, your call. I'm not going to force you to do it one way or the other. All right, so theta is my angle in radians, which is 2.5. That's equal to the arc length, which is 50 over the radius, which I'll call x now. And then we got a little simple cross multiplication. Good old days, right? Okay, so go ahead, cross multiply. 2.5x equals 50. Divide both sides by 2.5. Hopefully x ends up being, or r, whatever you ended up leaving it as, 20 centimeters. Okay, so that radius of 20 centimeters. All good? All right, next up, I'm going to let you guys do number 6. Okay, I'm going to let you guys stop the video. I'm going to stop it myself, write in my work, and see where we end up. Just be careful. Directions, find the diameter. Think about it, the diameter. All right, so go ahead, see what you can do. Okay, so here's my work right here. I did theta equals S over R, solve for R, got 7 centimeters. And since it asked for the diameter, I doubled it and got 14 centimeters. All right, so hopefully you and I are both on the same page there. All right, finally, to wrap this up here. Whew, all right, we got a cart, has a 2.4 radius. The cart travels from point A to B. What is the length of minor arc AB? Okay, so remember our terms from the second day, day 2. Minor arc means an arc that's less than 180 degrees. So I know I'm going to be solving for this arc right here. So what is that arc length? Well, go take a look, guys. Now my central angle is in degrees now. So you have two options. You use the formula from day 2 to find arc length in degrees, or you take your 165 right now and convert it into radians and use theta equals S over R. All right. You make that decision right now. All right. I'm stopping the video. You make that decision right now, which formula you want to use and if you need to convert or not. Okay. Okay. Just so I want to make sure I hook you guys up the right way. The one on the left to you guys is using the formula from day 2, which is measure of an angle over 360 times circumference. I got 6.9. And then the one on the right is I converted 165 to radians and got 11 pi over 12 in radians. And then I used theta equals S over R with 11 pi over 12. Either way, you'll see I got 6.9 meters. Okay, so it's really the decision you guys got to make. All right, do you want to really remember two formulas, which is fine? Or do you want to remember one, but have the ability to convert? All right, that's your call. All right, so let's sum up the last 2 days here, or 3 days actually, day 2, day 3, and day 4. All right, so if we want to change a degree to radian, what do I need to multiply by? So I have something in degrees. So 50 degrees, turn it into radians. We got to multiply by pi over 180. Okay, let's say I want to go backwards. I have something in radians, but I want to change it to degrees. Now I'm going to multiply by 180 over pi. And again, I know this doesn't mean much that we're virtual and not face-to-face, but these are on the formula sheet. Okay, arc length. Arc length formula if the given arc measure is in degrees. Given arc measure is in degrees. So now it's going to be measure of arc over 360 times circumference. All right. And then finally, what if I want to find arc length, but it's in radians? I can now use today's formula, which is theta, the angle measure in radians, equals S arc length divided by R radius length. Okay. So you guys hopefully are keeping all of these straight and figuring out what you're more comfortable with. Memorizing both arc formulas. All right. Are you comfortable memorizing both arc formulas or memorizing just one and then having the ability to convert back and forth? Okay. So hopefully you guys have made that decision and see what you can do on the homework. All right. Good luck, guys.